Okay, in this video, we are going to talk about percent increase and decrease. So what this means is we're going to be talking about the difference between two values. We're going to be talking about the amount of the change, and then we're going to talk about the percent change. So we're going to have an old value and a new value. And in order to have some kind of change, we're going to have the old value plus the change will give us the new value, and this would be if we have an increase because we're adding the change to it. And then we would have the old value minus the change would give us the new value when we're talking about decrease. Now, when we're talking about percent increase and decrease, the old value is always going to represent the base, which is our original 100%. Okay, so we're going to be using our circle again, P, B, and R. So our base, or our old value, is always going to go in this bottom left corner. Just a quick refresher, this line here represents division, and this line here represents multiplication. So let's go on to our first example. It says Maria Fay bought 4 Dunlap tires at a local Goodyear store. The salesperson told her the mileage would increase by 8%. Before this purchase, Maria was getting 24 miles per gallon. What should her mileage be with the new tires to the nearest 100th percent? Okay, so some key words here. First of all, we see that they're talking about two different values, and there is an increase. Because we have this word right here, increase, I know when I set up my equation, I'm going to use a plus. So I'm going to have the old value plus the change is going to give me the new value. And what I'm going to do is I'm going to use this to make a chart to organize the information, which will make it a lot easier for us to figure out what to put in our circle. So in the first row, I'm going to have the amount, so the amount of the old value, the amount of the change, and the amount of the new value. And then in the bottom row, I'm going to have what those values are represented in terms of percent. Now, because the old value always represents the base, we're automatically going to put in that the old value represents 100%. Now, in the problem, it says the change represents 8% in percent form. So I'm going to put 8% here for the change, which means when I take 100% plus the 8% change, the new value is going to represent 108% of the old value. The other information that's given to us in the problem is that Maria was getting 24 miles per gallon before she got the new tires. So that's the old value. So I'm going to put in 24 here for the old value. Now, we need to figure out what values to put in our circle. Remember, we always put the amount of the base in this bottom left corner. So that's going to be 24. So we're always going to use the old column, always. Now, depending on what the question is asking us to find, we're going to use the change column or the new column. Since the question is asking us to find her mileage with the new tires, it's asking us to find the new amount, so we're going to use this column. So we're trying to figure out what the new value is. So I'm going to put the new value here, and I'm going to put 108% in here. But remember, when we do our calculations, we have to use the decimal value, which would be 1.08. So when we work this out, we're going to get that the new value is 24 times 1.08. Now I'm using multiplication because what's separating the two values that I know is the multiplication line. And when we work that out, we're going to get 25.92. And we don't want to forget our units. This represents her new miles per gallon. So before she got her new tires, she had 24 miles per gallon. And now with her new tires, she's getting 25.92 miles per gallon, which represents an 8% increase. Okay. In the next problem, it says, in January 2015, the price of gas was on average $2.05 per gallon. This was $1.20 cheaper than the year before. So the year before is 2014. So that's the old value. And since the key word here is cheaper, that means it's going to be a decrease. So we're going to subtract the change. So minus the change is going to give us the new value in 2015. What is the percent in price decrease? So what we're looking for is the percent change for the decrease. I'm going to put a question mark there. Okay, so in the first row, we have the amount in the percent. Now, in 2015, it was $2.05 per gallon for gas. This was $1.20 cheaper, so this is our amount of the decrease is $1.20. Now, working backwards, we can figure out what the old value is, and that would give us $3.25. Because if I take $3.25 and I subtract the change, which is $1.20, that would give me the new value in 2015, which is $2.05. Now, remember, the old value is always 100%. We're always going to use the column that represents the base, and then depending on what it is that we're looking for, we'll use either the change or the new column. Since we're looking for the percent change or the percent decrease, we're going to be using this as our additional column. So in the circle, I'm going to put my change, my base, in the rate of change is what we're looking for. Since what we know is being separated by the division line, I'm going to divide to find the percent change. So the percent decrease is going to be equal to whatever I get when I take $1.20 divided by 325. And remember, since this is going to be a percentage, we have to multiply by 100 to put it in percent form. And the question also says round to the nearest hundredth. So we want to make sure that we round it to two places. So when I take $1.20 divided by 325 and I multiply by 100, rounding to two places, that gives me 36. That gives me 36.92%. So this is the amount it decreases. So what this is saying is, in 2014, the gas price was $3.25 a gallon. And the next year, on average, it went down by $1.20. And then in 2015, it was $2.05. And that $1.20 change represents a decrease of 36.92%. Next example, it says, assume in the year 2015, 800,000 people attending Christmas Eve celebration at Walt Disney World. In 2016, the attendance for Christmas Eve celebration was expected to increase by 35%. So here's a key word here so that I know that I'm going to add when I set up my equation because it's an increase. The question is asking, what is the total number of people expected at Walt Disney World for this event? So, since this is an increase, I'm going to set up my equation that the old value plus the change will give me the new value. I'm going to make my chart. So the first row will be the amount. The second row will represent the percent. The old value is always the base out of 100%. Now it says in 2015, the number of people is 800,000. So I'm going to label this here. I like labeling things because it helps minimize confusion. So this will be 800,000. It says we also know that it increased by 35%. So that is the amount of the change. So that's the percent of the change. Now when I take 100 plus 35, I get 135%. That's going to go underneath the new column. Now it says, what is the total number of people expected at Walt Disney World? And that's asking about the 2016 number. So we're looking for this amount here. So we always use the old column, and then depending on what we're looking for, we'll use that new value, or the new column, as the second value. So in my circle, I'm going to put my 800,000 for the amount. Remember, this is always the amount of the base. This is not a percentage, by the way. It's always going to be the amount of the base, not the percentage. And then we're looking for the new value, and the percent goes here. Now it's 135%, but when we put it in as a decimal, it would be 1.35. Now, since the two things that we know is being separated by the multiplication line, I'm going to multiply. So the new amount is going to be 800,000 times 1.35, and that's going to give us 1,080,000 people. So in 2015, there were 800,000 people. Then there was a 35% increase, so that in 2016, we have 1,008,000 people. Now, if we want to see the amount of the change in addition to that, we can just subtract the new and the old value to find the difference. Okay, the next example says Chevrolet raised the base price of its Volt by $1,200, and it raised it to $33,500. What was the percent increase? So here's a keyword, increase. So I know when I set up my equation, I'm going to use a plus. So I have the old value plus the change is going to give me the new value. Okay, the old value is always 100%. Now it says the amount that it changed was it went up $1,200, so I'm going to put that here. And it changed to $33,500. We can easily figure out what the old value was by working backwards. If the old value plus 1,200 gives me the new value, which is 33,500, I know my old value has to be 32,300. Just by finding the difference. Now the question is asking us to find the amount of the increase in terms of percent. So we're looking for this value here. So we always use the old column, and then depending on what we're looking for, we use that as our second column. So in my circle, I always put the amount of the base in this lower left corner, so that's 32,300. I don't know what the rate is. That's what we're looking for, but I know the amount of the change is 1,200. So, because the two values that we know is being separated by the division line, I'm going to divide. So to find the percent increase, I'm going to take 1,200 divide by 32,300. And because this is going to be a percent, I want to multiply it by 100 to put it in percent form. And the question says round to the nearest 10th percent, so that means one place. So when I put that in on my calculator, I'm going to get 3.7% for the price increase. Okay, next example, it says a major airline laid off 4,000 pilots and flight attendants. This was a 12.5% reduction in the workforce. What was the size of the workforce after the layoffs? So here's the key word, reduction. So I know that this is going to be a subtraction. So I'm going to take the old value minus the change, and that's going to give me the new value. So in the first row, we put all the amounts. In the second row, we put what that represents as a percent. Now, it says the amount of the change, what they did was they laid off 4,000 pilots. So I'm going to put 4,000 here for the amount of the change, and then the percent of the change is 12.5% reduction. Now we know the old value in terms of percent is always going to be 100%. Which means for this example, since I've got a subtraction, I'm going to take 100 minus 12.5%, and that's going to give me 87.5% for the new value. So if we start with the old value, which is the original 100%, and we decrease it by 12.5%, then the new value is going to represent only 87.5% of the old value. Now the question is asking for the size of the workforce after the layoffs. Now this one's a little tricky because we always have to use the old value plus the column that we're looking for. Now the reason why this one's a little tricky is because in this, if I use the new column right off the bat, since that's what we're looking for, I have two question marks. And I can't solve for anything if I have two question marks. So what we're going to have to do in this one is I'm going to have to actually use the change column and figure out what the old value is. Because once I know what the old value is, I can subtract 4,000 to figure out what the new value is. But I can't use two columns that have something unknown in both of those columns because there's not enough information to solve the problem. So I'm going to use the old column and the change column to solve this, and we're just going to have to do this in two steps. So this right here always represents the amount of the base. And if we use the two columns in red, the old and the change column, the old column is something that we don't know. So I'm just going to label that as old and leave that in there. We do know that the change is 4,000 and the percent for the change is 12.5. So when I put that in as a decimal, it's going to be 0.125. So what we're doing in this circle is we're solving for the old. So the old is going to be what I get when I take 4,000 divided by 0.125. Because what's separating the two values that we know is the division line. So when I take 4,000 and I divide it by 0.125, I'm going to get 32,000. So 32,000 is the old value. So the new value is going to be 32,000 minus the 4,000 that was laid off, which would give me 28,000 people. So this problem is a little bit tricky because if I go ahead and use the old and the new column right off the bat to try to solve for the new value, we have two unknowns and we can't do that. When we enter the information on the circle, we have to only have one unknown, and that's what we're solving for. So in a case like that, you have to use the other column and try to work out and figure out the problem in 2 steps rather than 1. Okay, last example, it says assume 450,000 people line up on the streets to see the Macy's Thanksgiving Parade in 2014. If attendance is expected to increase by 30%, what will be the number of people lined up on the street to see the 2015 parade? So here's a keyword so we know we're going to add. So I'm going to have the old value plus the change will give me the new value. This represents the amount, this represents the percentage. Now it says the amount that it changed in terms of percent was 30%. I know that the old value always represents 100% of the original amount. So because this is an addition, I'm going to get 130% for the new value. Now the old value, the amount of the old value is 450,000 people, and that was in 2014, and we want to know the new value in 2015. So I'm going to put 450,000 here, and we're looking for the number of people in 2015. So we always use the old column, and then in this case, since we're looking for the new value, we're going to use the new column. Now notice, it's different than the previous example. We only have one unknown, so this will work. So in my circle, I always put the amount of the base in this bottom left corner, which is 450,000. The new is what we're looking for, and then the rate goes down here. The 130% as a decimal would be 1.3. Because the two values that I know is being separated by the multiplication line, I'm going to multiply to find the new value. So the new number of people is going to be 450,000 times 1.30. And when I do that, I'm going to get 585,000 people. So in 2014, there was 450,000 people. Then it increased by 30% the next year, and we have 585,000 people. Now, if I want to figure out what that amount of the change is, not the percent change, but the amount of the change, I can just find the difference between the 450,000 and the 585,000 people.